Hi everyone and welcome to this my video on, I'm going to read it, I'm telling you, solving exponential equations using logarithms. You're like, huh? I'm like, I know, long title. This is part of my logarithm series for year 10. But again, if you're watching this in any other year, any other country outside of Australia, it is going to be hugely important. I promise you. Now, my name is Darren from Maths Guru. Thank you very much for finding me. If you head over to mathsguru.com and sign up, it's absolutely free. You can download the lesson notes I'm about to write all over and basically, well, you know, make the notes even better. Yeah, okay. But before you do that, can you subscribe to my YouTube channel? This is the needy bit. If you can subscribe, that makes my life so much better. Why? Because it means that people are watching it. And I know that people are watching it. And that you're finding it useful. And tell your mates and your teachers and all that type of stuff. And there's the needy stuff over, honestly, all the time. There's the learning objectives behind me. I'll recap those at the end. And fingers crossed, we will cover everything and more that you're going to need to smash this part of the course. Now, recapping my previous learning as such is, what have we been dealing with? Well, logarithms. It says it in the title. We looked at the rules in the last video. If you haven't watched the last video, it's available on mathsguru.com. That basically talks about how you can add logarithms, subtract logarithms, powers of logarithms, and some of the important logarithm rules there. And also how we can express big numbers in smaller numbers using logarithms, and I even did the pretty graph of what a logarithm looks like. We've done a lot, and now it's time to move on, because this is all about algebra and using skills, and the better you get, the more practice you do, the better you will get, and that's going to be massively important throughout this course. Now, what is an equation? Now, basically, equations and expressions, very, very different things. An expression is something like, oh, I don't know, x squared plus 4. That's an expression. Why? Because it's not got an equal sign in it. If I put an equal sign in it and say equals to, I don't know, 8, then I have something that I can then go away and solve. Yes? Now, when I was at school, we basically were taught that equations were effectively where two graphs intersect. And you'd be like, what do you mean? Well, in this situation, here is a parabola, x squared plus 4. That's my x squared graph that's been moved up 4 places. You've done that, lots of that in this particular year, of course. This here, believe it or not, is the line y equals 8. Now, if I was going to draw those on a set of axes, then basically I'd find out some points of intersection. If we look at the example I've given here, I've drawn two graphs. This was my original function, x squared plus 2x minus 5 equals 0. Okay, you've seen those. Your brain now is so preconditioned to going, oh, okay, then I'm going to, you know, T method it and null factor law it and that we've lost the point of going, well, you can do things in different ways. Now, when I was at school, we were told to write it in two different places. Sorry, try that again. When I was at school, we were taught to think of this as the line or the curve y equals x squared plus 2x minus 5, which on the diagram is this one here, and the line y equals 0, which just happens to be the x-axis. And getting used to that idea is really important. All right, so what we're really doing is we're trying to find the intercepts between the curve and the x-axis, right? And that's what actually happens. So when we solve that equation, we're finding those 2 points there, but we're finding them because they're points of intersection. What about harder questions? Can we use the same idea here? Well, absolutely we can, yes. Although when we get examples like 10 to the power of x equals 20, it becomes a little bit harder, because trying to use pencil and paper method, I mean, for a start, what does the graph of 10 to the power of x looks like? Well, I could use my CAS calculator or Desmos to be able to do that. And when I do it, this is what happens. There's my 10 to the power of x. If I also then draw the line y equals 20, which gives me this line here, then those points where they cross are the solutions, right? So in that situation, that's given me the solution that my x value would be 1.301, my y value would be 20. And it is so powerful thinking of these as y equals 10 to the power of x, y equals 20, and finding out that this value of y, when we put them equal, is where they intersect. All right, happy with that? Good. Hold on a moment. That graph looks nothing like a logarithm graph. Why did I use that logarithm graph? Well, I didn't. The textbook did, but we'll come on to those type of things in a little bit later. But you don't have access to Desmos? You don't have access to your graph thing? That's right, we can use the CADs to solve for this. And in this situation, I am showing the screenshot for the last pad.